June 2018 paper 4. You can use the chat to state the answer. The question 1, in a gas chromatography, time taken for a substance to travel through a column, what we call that is a retention time. This is the definition of a retention time, like how much time the sample will take to move through the column. This refers to retention time. Then propenyl chloride is formed when propanoic acid react with, like how acyl chloride can be formed, the formation when it reacted with PCl5. So D will be the right answer. Then there are different types of radiation which we can use. Like we can use infrared radiation, we can use microwave, different types of radiations are there. The question is, which type of radiation could be used to heat a chemical reaction? So chemical reaction, microwave or infrared radiation. Ultraviolet is used to break down the bond. Like if you want to break down the bond between the atom, we use ultraviolet light. Radio waves are used in NMR, nuclear magnetic resonance, in which we just like the atom, hydrogen atom absorb energy and it flip between the magnetic field. So the correct answer is A. Why not B? Because microwave can be used to heat, but ultraviolet to break the bond. Like due to ultraviolet light, if you remember, the homolytic bond breaking occur, it produces a radical. If you use a radio wave, the purpose of the radio wave is to just like absorb by the atom and it flip between the states, like flip between the magnetic field and release energy back. So in NMR, nuclear magnetic resonance, we use radio waves. So infrared heat radiation or microwaves can be used to supply the heat energy or make the substance warm. Which type of radiation is used to initiation step in which we produce a free radical? So which radiation is this? So ultraviolet or D will be the right answer. In question 4, this question is refers to the following molecules, all of which are having a carbonyl group. So the question is, a pale yellow precipitate is formed. So this is actually when alkyl group is there next to carbonyl group. This will give a like methyl group next to carbonyl group. So this will give a positive result. So yeah, methyl group, no, and this. So Y and Z only are giving the positive result. Because this is a test, triiodomethane reaction is a test to identify the methyl group next to carbonyl. The geometrical isomer is, as isomerism is shown by, to show like geometrical isomerism, we have to identify, like we have to check the carbon should have a double bond and different groups should be attached to a carbon. So when we check this one, so H2 means 2 hydrogen, so it does not exhibit a geometrical, because to show a geometrical isomerism, there should be different groups attached to a carbon which are having a double bond. So this cannot, when we check this one, X, so H is there and C double bonded with O and H is there, so this can exhibit. This does not have a double bond and this is having a double bond, but because again CH2, so it does not exhibit a geometrical isomerism. So we are left with only X. So X only, so B will be the right answer. Then a brick red precipitate on warming with a base. So which one is aldehyde? Because aldehyde give a positive result with Fehling or Benedict solutions. Aldehyde can be oxidized. So the option, this is aldehyde. This is aldehyde. This one is a ketone. This is then a ketone. Ene is there, but ketone. So which one give a positive result? W and X. And then propan-2-ol is formed when lithium tetrahydrodualuminate in dry ether is reduced to, it reduces what? Like basically aldehyde will reduce to aldehyde, or if a ketone is there, it will reduce to secondary alcohol. If aldehyde is there, it will reduce to primary alcohol. So when we check the option, pentanol, pent means 5 carbon, and pentane, which all is there? 2-ol. So when this will be reduced, 1, 2, 3, 4, 1, 2, so this cannot be even an answer because it will produce butane, 1, 2, 1, 2, 3, 4, 5. But then it will reduce, so there will be OH and OH will be there. So it will produce pentane 1-ol. But when this is reduced, reduction means addition of a hydrogen or removal of oxygen. So that is, it will produce pentane 2-ol. And when this is reduced, sorry, here this will be reduced. One, two, three, 1, 2, 3, 4, 5 are there. So as a result, what will happen? The OH, like OH will be attached here and H will be attached with the other one. One, two, three, four, 5 here. And it should form pentane 2-ol. But the problem, when we use lithium, A cannot be, we are left with either like X, Y, and Z. 1, 2, 3, 4, 5 are there. So this will become OH and this will become H. So this will produce pentane 2-ol. But here, when they are oxidized, when they are reduced, there will be double bond. So it will not produce pentane 2-ol. It will be pentene, because ene is double bond is there. So it will be ene. Same thing happened here. When it is reduced, it will produce a primary. So Y, and it can produce aldehyde, it can produce alcohol. This can also produce alcohol. But the problem, there's a double bond, so it does not produce N. It will produce ene. So that's why B is the right answer, that Y only will produce, because it is pentane 2-ol, not pentene 2-ol. If the last part compound, when it is reduced, it will produce pentene 2-ol. Okay, the continuation is the E and F part are also there. I thought only D. A molecule with a branched carbon chain is formed with a nucleophilic addition reaction with hydrogen cyanide in the presence of potassium cyanide with. So a molecule with a branched carbon chain. So if HCN is added, basically aldehyde and ketone both can react both have the tendency to react with this HCN, but it should form a branched. So when we check, here OH will be, look, the double bond will break, here H will be added and CN. So it won't be a branch, it will be 1, 2, 3, 4, 5, 6. So they're considered as a straight chain. When the HCN is added, so this will be H and CN. This won't be a branch because 1, 2, 3, 4, 5, 6. When this is added, so it will be a branch because if I count from here 1, 2, 3, 4, 5, so this will be a branch. And when here also HCN is added, so H will be there and CN. So if I count from this one 1, 2, 3, 4, 5, so this CH3 is the branch. So Y and Z, what they will produce? They will produce a branch compound as compared to. So in that case, Y and Z, so D should be the right answer. Then a mass spectrum with a fragment 29 would be expected for. So which mass spectrum we can expect, like 29 can happen for W, X, Y, and Z. So 29. So 29, I have to, like here, if to identify, just write the total mass of each part, like 12 plus 2, 14. This is 14. This is 12 plus 1, 13. So 14 plus, that will be 27. And if it is like this, 16 plus 12. So that is 28 plus 1, 29. So this will give, this is actually 29. This also 29. And if I count from here, this is CH3, CH2. So this is CH3 carbon 12, 15, and this is 12 plus 2, 14. So these two can combine to give 29. Like when we break from left to right or right to left, or up to down, top to bottom or bottom to top. And when I check for this one, this will be like 15 is there. This total is how much? 12 plus 16 to 28. So this can, the sum, like it can be either 15 or 15 plus 28. So it will be 43. And when I count from here, this is 12 plus 2, 14. And 12 plus 1, 13. So it will be 14 plus 13, 27. So it cannot be 29. It will be either 27 and then more than that, because that is 14 again. So 27 plus 14 makes 41. So it will be 41. So W, X, and Y will give the fragments at 29. Is it clear, this question 4, part E, part F? The equilibrium between the dichromate 6 ions to chromate can be represented by the equation. So whenever we are writing, it's a heterogeneous equilibrium. In a heterogeneous equilibrium, we don't include liquid or solid. We only use aqueous or gaseous. So that's right. For 5A is the right answer, because product divided by reactant only include the aqueous. As heterogeneous equilibrium, you are not including any other. Then addition of a small quantity of sodium hydroxide. So if I add sodium hydroxide, means I provide more OH ion. OH ion will react with these hydrogen ions. So amount of hydrogen ion in the equilibrium mixture will decrease. So equilibrium will shift towards right hand side. So I'll get more of the, like the solution will turn yellow as the OH which we add react with hydrogen. So it reduces the amount of hydrogen and shift the equilibrium towards the right hand side. So where the equilibrium shifts, it will shift towards right hand side. So D will be the right answer. Then The reaction between the sodium solid copper and aqueous silver nitrate, what are units for equilibrium constant for this reaction? Look, again, a heterogeneous equilibria, it is always a product divided by reactant. So copper ion I will include, and I will include silver, and then 2. The mole per dm cube divided by mole per dm cube square. So always check the state symbols, because if they are all in same symbol, then we'll include all of them. But if they are different, then we'll use only the aqueous ones. So mole per dm cube divided by mole per dm cube square. So when we simplify this, like this will cancel with, so we are left with 1 over mole per dm cube. Dm cube will come there in numerator, so dm cube divided by mole, or dm cube divided by mole means dm cube mole minus 1. So even though the question appeared to be very simple and straightforward, but if you miss this part that it is a heterogeneous equilibrium, then you will just use all the reagents and find the unit of Kc. In question 7, which is about the Kp, the Kp is 1.8 at 250. The expression for the partial pressure, the partial pressure is the moles of a chlorine divided by total into total pressure. So A is the right answer. Then the equilibrium partial pressure for PCl5, phosphorus pentchloride, and chlorine are 0.61 and 0.946. What is the partial pressure in ATM for phosphorus chloride? Because we can work out by using the formula, like Kp is equals to the pressure of product, like pressure of PCl3 multiplied by pressure of a chlorine divided by pressure of PCl5. So Kp is 1.8, PCl3. The equilibrium partial pressure for phosphorus, that is given 0.614, that is given 0.946, and this we want x. So we cross multiply, so it will come out as 0.32. If we know the total pressure, we can subtract their partial pressure to get the total, but we don't have the total pressure. That's why we are using the value for Kp. Question 8, methanol is produced by catalyzed reaction between carbon monoxide and hydrogen. The equilibrium yield of methanol is favored by, like if you want to, if forward reaction is exothermic. So exothermic reaction prefer low temperature. So the temperature should be, because the forward reaction is exothermic, so we should lower the temperature, or we should decrease the temperature to get. And what about the pressure? We have 1 + 2, 3 moles, and here we have 1 mole. So if we increase the pressure, the equilibrium shift towards side where number of moles are less. So high pressure and low temperature should be used. So A should be the right answer. Sorry, B should be the right answer, because our forward reaction is exothermic. The equilibrium constant Kc for this reaction has a numerical value of 3.64 at a certain temperature. This value of Kc means that at this temperature, now what is the meaning of a Kc? Basically, Kc is what? Kc is a product divided by reactant. So Kc is equals to product. Kc or Kp is product divided by reactant. or as I mentioned, numerical value is 3.64. So 3.64 is equals to product divided by reactant, or 3.64 times the reactant is equals to product. So the numerator in the Kc expression is 3.64 times larger than the denominator. That is true. Like you can see, if you 3.64 multiplied by the denominator reactant, will get the numerator. So see, basically Kc or Kp is showing a ratio between the product and reactant. Higher value of a Kc means more product at equilibrium. Smaller value of a Kc means smaller quantity or amount of a product at equilibrium. So using the Kc or Kp, we can predict whether a reaction goes on completion or still the reaction does not even start if it is having a very small value. The energy cycle for dissolving of a magnesium chloride is given. What is the enthalpy change of a magnesium ion? The enthalpy change of a magnesium ion is minus 1920. What is the enthalpy of hydration of chloride ion? So the formula, you can use the formula or you can use your understanding of the Hess law. Remember, where the two arrows are pointing out, that is the start of the cycle. So where the two arrows are pointing out, that is the start of the cycle. Where two arrows are pointing in, that is end of the cycle. So we can see the two arrows are pointing out, so that is the start of the cycle. And here the two arrows are pointing in, that is the end of the cycle. So according to Hess law, if I follow route 1, if I follow path 1, or I follow path 2, the overall energy change does not depend on the route. So the energy change of a route 1 will be equal to energy change of the route 2. So what is the energy change of route 1? That is first one, the lattice energy. So I can say minus 2526 plus the enthalpy of a solution is minus 148 equal the energy change of route 2. So what is the energy change of route 2? One magnesium ion is there. Enthalpy of hydration of a magnesium ion, that is minus 1920 plus that is the hydration of 2 chloride ions, so it will be 2x, 2 times the hydration of chloride. Then we simplify this. So minus 2526 minus 1400, minus 148 plus 192, plus 1920 equal to 2x, or when we simplify, minus 2526 minus 148 plus 1920 divided by 2 will be equal to x. So this will give us B minus 377 will be the right answer. This is one way of solving this question. There is also another way, the formula which relate the enthalpy change, hydration energy, and the lattice energy with the enthalpy change of a solution. So direct formula is there. Enthalpy change of a solution is the hydration minus the lattice. And what are the hydration energy? We have a 1 hydration of a magnesium ion, and we have twice the hydration of a chloride. And the formula minus, and then this is a part of a formula, minus the lattice energy So minus lattice energy is equal to enthalpy of solution. So we'll substitute enthalpy of solution here. Lattice energy is given minus 148. That is the lattice energy, and magnesium hydration is given. So we can work out for chloride as well. So hydration minus lattice, that is one way, or you can, if the cycle is given, so you can use the overall energy change does not depend on the route. So you can follow route 1 energy will be same as route 2 energy. The enthalpy change of a hydration of a potassium is less exothermic than magnesium. What is the reason for that? If the bonds are stronger, the hydration energy is higher. If bonds are weaker, the hydration energy, and hydration energy depends on two things. It depends on the charge and the size. The charge on the ion should be more and the size of the ion should be small so that it can form a strong bond. So charge divided by size is called a charge density. So magnesium is having a smaller size and greater charge. Potassium will have a large size and small charge. So potassium will have a smaller charge density. That's why its lattice energy is lower. Then the last question, chloric 1 acid, HClO, and nitric acid, HNO2, form the equilibrium, as you can see here, the Bronsted acid and its conjugate base. So acid, like when we mix two acids together, the one which loses proton, acids are proton donors and bases are proton acceptors. So for a forward reaction, HNO2 is donating, so it is acting like an acid. Forward reaction, this is acid, this one is base. So what is the acid for a forward? That is HNO2. And for a reverse, when we check for reverse, first it is H2ClO become HCl. So it means it donates, so it is acting like an acid. So this is acting like a base. So what is the conjugate acid base pair? So this is acid, so its pair is NO. And H2ClO, its pair is HClO. So the conjugate acid is HNO2 and its base is NO2 minus. So C is the right answer.